सोडियम आयन बैटरी एक नई प्रकार की बैटरी है जो विद्युत के भंडारण के लिए उपयोग की जा सकती है। यह एक उच्च ऊर्जा देने वाली तत्व होता है जो आमतौर पर लिथियम आयन बैटरी में पाया जाता है। The concept of using sodium ions as a charge carrier has been around for several decades, but the technology has only recently started to gain traction as a viable alternative to LIBs. The main reason for this is that sodium ions are much more abundant and cheaper than lithium ions, making SIBs potentially more cost-effective than LIBs. इस बैटरी का निर्माण सोडियम आयन के ऊतकों का उपयोग करके किया जाता है। सोडियम आयन बैटरी लिथियम आयन बैटरी के मुकाबले कम कीमत वाली होती है। सोडियम आयन बैटरी में विद्युत ऊर्जा का स्टोरेज करने के लिए सोडियम आयन का उपयोग किया जाता है। The basic structure of a SIB is similar to that of a LIB, with a cathode, an anode, and an electrolyte separating the two electrodes. The cathode is typically made of a sodium metal oxide, while the anode is made of a carbon-based material. The electrolyte used in SIBs is usually a sodium salt dissolved in a solvent such as ethylene carbonate. एक सामान्य बैटरी में धातु आयनों का उपयोग किया जाता है जो बैटरी की ऊर्जा के संचय को संभव बनाते हैं। इसके अलावा बैटरी की ऊर्जा का संचय करने के लिए लिथियम और कोबाल्ट के जैसे अन्य धातु आयनों का भी उपयोग किया जाता है। During the charging process, sodium ions are extracted from the cathode and moved through the electrolyte to the anode, where they are stored. When the battery is discharged, the process is reversed, and the sodium ions move back to the cathode, releasing energy in the form of electrical current. One of the main advantages of sodium over lithium is their ability to operate at high temperatures. This is because sodium ions are larger than lithium ions, which means they can move more easily through the electrolyte at high temperatures. This makes more suitable for use in high-temperature environments, such as electric vehicles, where lithium can sometimes struggle. Another advantage of sodium is their potential to be more environmentally friendly than lithium. This is because lithium is a relatively rare element that is mostly mined in a few countries, such as China and Chile. This has led to concerns about the environmental impact of lithium mining and the potential for supply chain disruptions. In contrast, sodium is much more abundant and can be sourced from a wider range of locations. सोडियम आयन बैटरी की तुलना में लिथियम आयन बैटरी के उपयोग में कुछ फायदे हैं। Despite these advantages, SIBs still face several challenges that need to be overcome before they can be widely adopted. One of the main challenges is developing high-capacity cathode materials that can store large amounts of sodium ions. Another challenge is improving the performance of the electrolyte, which can degrade over time and reduce the lifespan of the battery. In conclusion, sodium-ion batteries are an exciting new technology that has the potential to offer several advantages over lithium-ion batteries. While there are still challenges that need to be addressed, the development of SIBs could lead to more cost-effective and environmentally friendly energy storage solutions for a wide range of applications.